Hello. Today we're going to look at section 10.7, which is about polar coordinates. Our goals for today are that you can plot points in the polar coordinate system, convert points between polar and rectangular forms, convert equations between polar and rectangular forms, and for those of you that would like, there's a little bonus activity that I'll be posting about using technology to graph polar equations. Let's start with a few definitions. In the rectangular coordinate system, that is the coordinate system that you are used to, every point P represents the directed distance from the x and y axes to the point, right? The x coordinate tells you how far to go along the x-axis, the y coordinate tells you how far to go in the y direction, and you end up at your point. In the polar coordinate system, each point P is represented with polar coordinates r comma theta, where r is the directed distance from a reference point O, and theta is the directed angle from the polar axis to the segment. So r tells you how long this segment is, and theta tells you how far this angle is to get you to the point P. All right, so we're going to take a look at some examples of plotting points in the polar coordinate system. Don't feel like you need to write this example down so much. It's a lot easier to do if you have polar graph paper, but I want you to understand a little bit better how polar coordinates work. So the first point we're going to graph is 3 comma negative pi over 3. So this is a slightly fuzzy polar coordinate graph. But if I was going to graph this point, I would go over to 3, so to represent a radius of 3. And then negative pi over 3. You're going to see a lot of tie-ins today to our unit circle. I know how much many of you love that unit circle, right? So we go over to 3. Negative pi over 3 is coterminal with 5 pi over 3, or the other way you can think about it is, right here is positive pi over 3. We would want to go that same distance around in the opposite direction to get to negative pi over 3. So third radius out, negative pi over 3, that's right here, we plot our point. Next up, 2 comma pi over 6. So I go over to a radius of 2, and then go around till I get to an angle of pi over 6. I plot my point. 2 comma negative pi over 6. I would go again to my radius of 2, but this time instead of going to positive pi over 6, I'm going to go in the negative direction. There's my point, negative pi over 6. Okay? So that's what points look like in the polar coordinate system. Our bigger goal for today, though, is that we can convert between these two coordinate systems. So if we have a point in the rectangular system, it would be x comma y. In the polar system, it would be r comma theta. But here you've got a diagram that shows all the different pieces of that. Okay, x, y, here's our r, and here's our theta. So if we want to go from polar to rectangular, we call that, we can say the cosine of an angle is equal to the adjacent side over the hypotenuse. So we can say cosine theta equals x over r. Well, if you multiply both sides by r, you would get x equals r times cosine theta. Same idea to get our y-coordinate. We know the sine of our angle would equal our opposite side y over our hypotenuse r. And then if you were to multiply both sides by r, you would get y equals r times sine of theta. So if you know your polar coordinates, these are the equations you would use to get them into rectangular form. If we want to go the other way, if we have our rectangular coordinates and we want to get to polar coordinates, well, to find our angle, we know that tangent is the opposite over the adjacent. So we can say the tangent of our angle is equal to our opposite side y over our adjacent side x. And to find r, well, hey, this is a right triangle, so we can use the Pythagorean theorem and say x squared plus y squared is equal to r squared. So we're going to be using these 4 equations to convert between rectangular and polar coordinates, and we actually also use them for converting between the 2 types of equations. So we're going to take that point that we plotted earlier, 2 comma pi over 6, and we're going to convert it to rectangular coordinates. Now, you're either going to need to know your unit circle, or you're going to use a calculator, making sure that it's in radian mode because our angle is being given to us in radians here. You can decide which way you want to do these, However, it's actually a little bit easier if you have your unit circle than it is to do it with a calculator, but I'll talk about both ways. Okay, so 2 comma pi over 6 is in polar form. So we know r is 2 and theta is pi over 6. We're going to substitute those values into our equations. X equals r cosine theta and y is equal to r times sine theta, and then simplify. So x equals r cosine theta, so 2 times cosine pi over 6. Well, the cosine of pi over 6, either looking at your unit circle or typing that into a calculator, would give you root 3 over 2. And so if we do 2 times square root 3 over 2, we get square root 3. If you're using a calculator, you could type this all in at once and just get that square root 3. For our y value, 2 times the sine of pi over 6. Well, the sine of pi over 6 is 1/2, and 2 times 1/2 is 1. So our rectangular coordinates, our x coordinate is square root 3, comma, our y coordinate is 1. So going from polar to rectangular, fairly friendly. Just plug them into the equation, do a little bit of simplifying. The other direction, a little more fun. Let's take a look. So this time we're going to convert -2, comma 2 into polar coordinates. You need to figure out what quadrant your point is in, especially if you are using a calculator instead of using your unit circle. Okay, so if you think of the point -2, 2, if we go -2 in the x direction and then down 2 in the y direction, or up 2 in the y direction, that would put us in quadrant 2. We know our x coordinate is -2, our y coordinate is +2. Next, we're going to find our angle using the equation tangent theta equals y over x. So we have tangent theta equals y is 2 over x is -2. Well, 2 divided by -2 is -1. So tangent theta equals -1. Now, to actually find theta and not tangent of theta, you can either use your unit circle or you can use a calculator in radian mode. If you're using the unit circle, you just go look in quadrant 2 for the angle that has a tangent of -1. If you're using a calculator, you need to be aware that your calculator is not necessarily going to give you the angle that's in the correct quadrant, and we'll talk about that more in a moment. So if you use your calculator, you would do the inverse tangent of -1, and that would, your calculator would tell you that's -pi/4. Well, if you think about the angle -pi/4, that is not in quadrant 2. So you have to find an angle with the same tangent that is. And to do that, you would do -pi/4 plus pi, which would give you an angle of 3pi/4. So we found our angle. We also need to find our r. To do that, we use our equation r squared equals x squared plus y squared. So plug in -2 for the x, +2 for the y. -2 squared gives us +4. +2 squared is also +4. And 4 plus 4 gives us 8. So if r squared equals 8, then r equals the square root of 8. And if you simplify square root of 8, that is the same as 2 root 2. Please simplify your radicals if you can. So our polar coordinates are 2 square root 2, comma 3pi/4. All right, so let's talk about how this step here worked. Okay, and so let me move on here. So here's a picture of my beautiful unit circle that I color-coded with you all during first semester. And you might recall when we first started talking about inverse tangent and graphing inverse tangent, that the defined range for the inverse tangent is from -pi/2 to +pi/2. So when you use that inverse tangent button on your calculator, it's always going to give you an angle in between those two. It's going to give you an angle here between -pi/2 and +pi/2. Well, that's not always the angle you want for these problems. Particularly if you're doing your assignment on WebAssign, it's going to require that you give an angle between 0 and 2 pi. Okay, so if the point you're working with is in quadrant 1, the angle that your calculator gives you is the correct angle. If the point that you're working with is in quadrant 2, like the one that we just did, we would need to add pi, because what's going to happen, like we saw here, is our calculator said, oh, the inverse tangent of -1 is -pi/4. Well, the spot that also has an inverse tangent of -1 is halfway around our circle. Now, all the way around was 2 pi, halfway around is pi. That's why we're adding pi to the angle that our calculator gives us. Okay? If the point that you're given is in quadrant 3, your calculator is going to give you an answer that's over here in quadrant 1. So again, you would need to add pi to that to get an angle that's over here in quadrant 3. If the point that you are given was in quadrant 4, okay, your calculator is going to give you one of these angles here. It's going to give you a negative angle. Well, to get to a positive angle, you just need to find an angle that's coterminal with the angle that you were given by your calculator. So you would add 2 pi to that. So for example, if the point that we had been given was 2, negative 2, our calculator told us, oh, the inverse tangent for that is negative pi over 4. Well, negative pi over 4 plus 2 pi or plus 8 pi over 4 would take us to 7 pi over 4, which would be the angle that we would need to write for our coordinates, so that we would be in between 0 and 2 pi. All right, so let's try another one of those. We're going to convert negative square root 3 comma negative 1 to polar coordinates. Okay, so again, think about what quadrant you're in. So we went negative in the x direction, and we're going negative in the y direction. So that's going to put us in quadrant 3. We know our x coordinate is negative root 3. Our y coordinate is negative 1. Okay, so we're going to find our angle using our tangent theta equals, oops, sorry, there's a little typo there. That should be y over x. I'll fix that before I post the PDF of this. All right, so tangent theta equals our y value of negative 1 over our x value of negative root 3. Well, a negative divided by a negative is a positive. Okay? If you're just typing this into your calculator, you don't need to simplify it, but especially if you're using your unit circle, you would want to rationalize your denominator here. If you multiply by square root 3 over square root 3, 1 times the square root of 3 is square root 3. Square root 3 times square root 3 is 3. So looking at your unit circle, you would look for an angle in quadrant 3 where the tangent is positive root 3 over 3. If you're using a calculator, you're going to type in the inverse tangent of square root 3 over 3, and it's going to tell you that's pi over 6. Well, if you think about pi over 6, that's in quadrant 1, not in quadrant 3. So if you add pi to that, you would get the correct angle of 7 pi over 6. Use your Pythagorean theorem-based equation here, r squared equals x squared plus y squared, to find your value for r. So r squared equals x negative root 3 squared plus y negative 1 squared. Well, negative square root 3 squared is 3. Negative 1 squared is 1. 3 plus 1 is 4. So we have r squared equals 4. We take the square root, we get r equals 2. So our polar coordinates are 2 comma 7 pi over 6. All right, so we've done some work with these equations to convert between rectangular and polar coordinates. We're going to use these same equations, but this time we're going to be converting between rectangular and polar equations. So here we're going to convert each rectangular equation to polar form. And we're going to stick with fairly friendly equations. There are much more complicated equations that you can use, especially in our next example when we go from polar to rectangular. That would require all kinds of algebra tricks we are not going to get into. Okay, so sticking fairly friendly here. So we know this equation, x equals 5. We want to get that into an equation that has r and theta and does not have any x's or y's. There aren't any y's in this one, but you get the idea. Okay. So we happen to know that equation that we saw before, x equals r times cosine theta. So we can replace x with 5 and get 5 equals r cosine theta, or r equals, r cosine theta equals 5. And now we'd like to get our equations to have r by itself on one side, typically. So if we divide both sides by cosine theta, we have r equals 5 over cosine theta. We'd like to make that look a little bit friendlier. We'd rather not have a fraction if we don't have to. And we know that secant theta is equal to 1 over cosine theta. Hey, we're bringing in lots of review back from first semester here. Okay, all those trig identities, not all of them, but some of the nicer ones. Okay. So since secant theta equals 1 over cosine theta, we can replace 1 over cosine theta with secant theta and get, and I apologize, I have another typo here. This should be r equals 5 secant theta. Oh, just a day for typos. Oops. All right, let's try another one. X squared plus y squared equals 81. Okay, so we have an equation this time, one that has both x and y. So thinking back to those 4 equations on our converting slide, okay, the one that has, well, one of the ones that has both x and y in it is the one that says x squared plus y squared equals r squared. So we can replace x squared plus y squared with r squared and get r squared equals 81. If we solve that to get r by itself, take the square root of both sides, we get a polar equation of r equals 9. All right, so let's go the other direction, having a polar equation, putting it into rectangular form. And the first one we're going to take a look at is r equals 10. Again, so we have an equation that has r. We want an equation with x and y. Well, we know x squared plus y squared is equal to r squared. So if we square both sides of this equation, we would get r squared is equal to 100. And then we can replace r squared with 100 and get x squared plus y squared is equal to 100 for our polar equation. Our last example here, r equals 7 cosecant theta. Okay? Recall that cosecant of theta is equal to 1 over sine theta. None of the equations that we saw earlier had a cosecant in it, so I'd rather get this into something that has a sine or a cosine in it so that I can use one of the equations that I already have. So if we replace cosecant with 1 over sine theta, then now we have r equals 7 over sine theta. Or if you multiply both sides by sine theta, you have r times sine theta equals 7. And now this should look very similar to one of the equations that we saw before, that y is equal to r sine theta. So if we just replace r sine theta with y, we get a rectangular equation of y equals 7. For many of you, your challenge on these problems is going to be to decide which of those 4 equations, the x equals r cosine theta, the y equals r sine theta, the tangent theta equals y over x, or x squared plus y squared is equal to r squared, deciding which of those 4 is the most helpful one to use to help you convert. And you may find yourself trying a few different things to come up with one that's the friendliest option for you to use.